we have developed the understanding that pi radians is 180 degrees. And that is because to get all the way around the circle takes 2 pi radiuses. So halfway is pi radiuses. And radians is number of radiuses. Okay. Neat. Okay. So let's see. All right. That still doesn't answer your question. You're like, that's great. How do you do it? So if I said, can you please convert? In fact, is that on the practice test? Do I have one that just says 60?
Yeah.
Ooh, I'm so evil. Of course, practice test, I could be evil if I want to. How do I convert that? What units is that? No, we don't assume in it. If you make an assumption, you make an ass out of you and umption, so don't do that. So what is that? That has to be what? That has to be radians. Why?
Because it's not in degrees.
Doesn't say degrees. There you go. That's it. Now, why is that evil? Because 60 degrees is like a normal little angle we talk about, so that's evil. But I don't care, because it's a practice test. So how do I convert? That is currently radians. You can write it there if you want to. So somebody help Ethan out. How do I know how to set up the other part of that grid? What unit do I want to kill? Radians. Radians must die. So I want to put the radians down here so they die. And up here I'm going to put degrees. So now I know where to put what number. Yeah, 180 degrees by radians. And I just throw all that shit in the calculator. It's obviously going to be freaky as shit. Can somebody tell me roughly, and I already said this, but I want to know the decimal. Roughly how many radians to get all the way around a circle? I almost said triangle. Look at the triangle.
6 pi.
Say again? 2 pi, and pi is roughly 3 point something, so all the way around is roughly 6 point something, 6.28, blah, 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 blah. You guys with me? So 60 radians is like 10 times around the circle almost. Are you with me? And that's a lot of freaking degrees. So when you throw this in your calculator, you should get kind of a large answer. So 3,500 something? 3,000 something, I'm sure. I don't remember. I did the answer.
Put that in the calculator, it would just be like 60 times.
60 times 180 divided by pi. Yep. That's great. When you do the grid, whatever's on the top you multiply by it, whatever's on the bottom you divide by it. It's crazy.
Yeah, 2,400.
All right. And again, do you guys see how it makes sense? This is about 6.28. 60 frickin' radians is a lot of travels. Yes? It's a lot of rotations. Okay. In fact, let's do this. What would 10 rotations be in degrees? One rotation in degrees is 360. So 10 rotations would be 3,600, and that's a little less than 3,600. No way. Okay. Do you have to know everything I just said? No. You only have to do this. I'm just trying to show you why the answer makes sense that it's so big. Because 60 radians is actually a lot.
And we go from degrees to radians.
Yeah, so if I had, here's a great thing. What's really nice about a problem like this, if I want to take that to degrees? Tell me what pi is again? Pi radians is 180 degrees. That's the beautiful thing. Right? I mean, if there's a pi in my radians, I can replace it with 180 degrees. If it's on the top, just to be careful. Somebody could be mean. If I have degrees, what do you got, Jeff? Sure. How do I convert that to radians? Yeah, I want to kill degrees. So I want to change it to radians so the degrees die. Now I know where to put my numbers. The numbers go next to the right unit. Now don't plug this in your calculator. You should try to reduce it, right? Because normally radians are like pi of 6. So we try to reduce 48 and 180. I really don't want that as a decimal. We should be used to like 5 pi over 6 and 11 pi over 4 and all that crap. Okay. Is that okay? Read. Some of you guys look concerned, but you're not saying anything. So that was the first problem, I think, on the practice test. Second problem, yeah. First problem was a good old standby. Very first thing we did with trig, making those ratios. Does anyone need a copy of this? Oh, you also need potentially other stuff. Did you get one of those? Oh,
I did. I was finishing up
it's
the
one side
my
resume.
homework and I left it at home.
Good one. Okay. So listen, do you guys, let me throw something out there. Does anyone have any other questions at the moment? Yes.
For question 4.
Which one?
Question 4.
4. Oh yeah, okay. This one looks weird. But what information do I give you? Yeah. So I tell you the value of secant, and you know what the ratio that secant's related to, what it gives you. What else do I tell you? This is something students kind of gloss over. What else do I tell you in number 4?
Well, we have all the stuff.
Say again?
We have side lengths for 2 side.
Okay, secant theta gives you the side lengths, so you can draw a triangle. But what else do I give you? What other information do I give you?
Angle.
What does this mean? Look at this.
The domain.
Not really. Not really a function. It's just the value given an angle. I'm just telling you what quadrant the angle lives in. Alright, let's do it this way. Secant theta is 25 over 24. What angle, what quadrant could that be in? How do you guys even answer that question? If I say secant theta is positive, what quadrant could I be in? Could be the first. Where else is secant theta positive? Secant theta is 1 over 1 over cosine. When is cosine positive? Cosine's positive when x is positive. When is x positive? First quadrant? Fourth quadrant. Good. So look at this again. What did I tell you? That's fourth quadrant, yes? That's from 3 pi over 2 to 2. That's fourth quadrant. And then matches with secant being positive, thank you God. So past Jeff paid enough attention to make those actually match up. Now listen, there are 2 ways to do this. On the answer key, I actually did it the way I don't normally do it. So I'm going to do it the other way. I'm going to show you the way I normally would do this. Can somebody help me draw this triangle? I don't mean like this. Can somebody help me figure out what side is what? And don't forget, look. If you don't like secant, you can immediately make it cosine. If secant theta is 25 over 24, what's cosine?
24.
There we go. Now we got 2 of the 6 total, yes? So where's 24 go?
The bottom.
On the bottom. Where's 25 go?
Hypotenuse.
Hypotenuse. So what am I missing to figure out the other 5 trig functions? I'm missing this side, yes?
Yes.
And if you do, what do I have to do to figure that out? Yes, old Greek dude is the right answer. Old Greek dude. And if you do it, you'll get 7. Yeah. So you all know 3, 4, 5. Some of you guys know 3, 4, 5. That's a triangle we used a few times. There's a 3, 4, 5 right triangle. 5, 12, 13 is another one. 7, 24, 25 is another one. There are several in the universe. Most right triangles will have radical sides because they're related through squares. Some have whole number sides. That's good for them. if I do it this way, what I'm trading off for ease of drawing is the fact that I got to remember I'm in the fourth quadrant, yes? So, for example, what's sine theta? Don't overthink it. What's sine theta?
707.
And what do I have to add to that? Or do I have to add anything to that?
You mean like if it's positive?
Yeah.
That's
Fourth quadrant, y is negative, yes? So if you do it this way, you can draw the triangle, pay attention to the ratios, but we just have to throw the negatives in the right place.
Yeah.
You guys with me? I did it on the answer key a different way. I can show you what I did, but I mean, do you guys see what I'm saying? Now you can run through all of them easy. In quadrant 4, what's the sine, SIGN, of tangent and cotangent?
Negative?
Negative, because sine and cosine have different signs.
Yeah.
So the only positive things here are these two things. Everything else is negative. So many problems. The SIGN, positive, negative, and the number are things I think of separately. And that makes the problem easier. The number gives me these, and the quadrant gives me signs. And one way to do it is to think of them each separately. The other way to do this is to actually put our triangle in the fourth quadrant. This is 7, but since it's going down, it's negative. This is positive, so this is positive 24, and the hypotenuse is always positive. And now when I make all my ratios, the right things will show up to be negative, yes? So that's negative 725. Tangent, cotangent, they'll both be negative.
Yeah.
So that's the way I did on the answer key, because I think that's the way most students like to do it from my experience, but a few people like my way. Just separate, get the numbers, and then put the negatives in the right place. Yes? Either way works.
Just to clarify, just to make sure I understand this right, we know the angle so that we can determine what the SIG is.
We know the quadrant,
Yeah.
so I know my angle lives between those, and that's quadrant 4.
Yeah,
And then I know the SIGN of all the trig functions. So that's why this works. If I just focus on the physical triangle and I do the numbers, I can just put the negatives in the right place. Or I put the negative in the right place to begin with, but then my triangle looks a little bit funkier. Bit of a trade-off. Maybe.
Isn't there a third way to do it?
There's probably 12 other ways to do it. Are you kidding me? I think I told you guys there's like 50-something proofs of the Pythagorean theorem that I've personally seen, and then I know there's hundreds more that I decided I'm okay, I'm good. I think I believe it. I think I'm good now. Yeah. For example, so there's always about 1.2 billion different ways to do something. And just to remind you guys, based on what I just said, as long as you show me what you're doing, there's so many different ways to do these problems than just the way I'm showing you. So if something other than what I do makes more sense, as long as you show me what the hell you're doing, sometimes, you know the way that I teach difference of cubes and sum of cubes? I stole that from a student. Well, parts of it I stole from one of my students. Because they were doing, when they broke it up on the paper, I was like, oh my God, I'm gonna start teaching it that way. So I definitely don't mind if you guys do shit a different way, I could steal it from you and use it next semester. Why not? Or do it the way I do it, who cares? As long as it gets done and understood. Is that problem okay? So you got two main ways of doing it.
And to find the angle, you would do like inverse of...
Yeah, in fact, I think I didn't do this on the answer key. Because in my other class, I gave them this practice test before I even talked about inverse stuff. But for example, right here, I can figure out the value of theta right here. How could I solve for theta?
Inverse of...
Inverse, inverse sine.
Yes.
Now, what's interesting is, well, this will work out. You'll get like a negative answer, and it's still in the fourth quadrant, but I did say that theta is supposed to be between those two, yes? So that'll be your reference angle, then you can get your actual angle. So let's kind of do it. Can you guys help me out?
I got 16.260.
16.26,
Yep.
and it's negative, yes?
Negative, yeah.
Okay, good. So then, what would the actual angle be? So we got negative 16.26, so what is this?
340.
Yes, you would take 340 minus 16.26. I'm sorry, 340. 360 minus 16.26. So you get what'd you say, 43.74?
739.
Yeah. You guys semi with me? Because I said theta is supposed to be between 3 pi over 2 and 2 pi. You get a reference angle when you do inverse sine. Okay, yes sir.
So for this, do you want us to give the angle or like the function?
No, 2 steps. Find the other 5 trig functions, so we started doing that here, yes? That's the easy part. And then it said, then find the value of theta.
Yeah, okay.
So it's 2 separate things to do. And you can take any of your trig values. You could have used this from the beginning and done inverse cosine, yes? That would have been better actually. Can you do inverse cosine of 24 over 25? Why is that even better? Because inverse cosine lives between 0 and 180, and that covers all possible. So it's going to give us 343. No, it's going to give us, actually, it's not going to give us 343. It's going to give us 163.74. Did anyone do inverse cosine of 24/25? Actually, no, it's going to give us 16.26.
Yeah.
Okay.
Just probably.
And then I still have to put it into the 4th quadrant. Yeah.
But again, for this, we don't need to like visualize the way we usually like with the graph where we have like the negative triangle and goes down.
Those 2 different ways to do it.
Yeah.
You can do it this way, as long as you remember to put the negatives in the right place, or you can do it this way where the negative is already built in. Either way. I prefer the first way. Yeah.
Sine is negative on
Wherever y is negative.
the right hand. Cosine is x negative.
Yeah, wherever x is negative.
Second and forward.
Second, third for cosine,
Yeah.
and then third and fourth for sine.
Yeah.
Yeah. Something that SOHCAHTOA can't tell us at all. Is that you SOHCAHTOA sucks?
Yeah.
Sorry guys.
Still don't.
Some of my teachers, no, not my teachers, some of my students, they don't understand, and that's fine, because SOHCAHTOA feels good, but it doesn't extend. So when you start doing calculus and other stuff, SOHCAHTOA is going to go out the door. It's not going to mean shit to you.
SOHCAHTOA can suck a toe.
Huh? Suck it, yeah. It can suck a toe, yes. Trent gets a gold star for the joke. Put it up on your fridge. All right, where do you guys want to go next? Is that number 4 okay?
Yeah.
Yeah? Some of this stuff feels like it's been forever since we did it, but I mean, reference angles and stuff, yes?
Yeah.
So listen, how many of you guys actually did most of the practice test? Anybody? Okay, let's do this. Whoever says something first, which problem would you like to work on as a group and then attack together? Oh, by the way, number 10 I said we'd do in class. So we might as well do that one. So guys, try 10A. Of course, what's 10 all about? What's 10 gonna use?
Law sine, law cosine.
Okay. It's gonna use law sines or law cosines. How do you determine which one you can use?
Aim side sine, so.
No. Not if it's law sines, will it be a but about it?
Okay.
How do you determine which law to use?
We have integration.
You must find a lawgiver. So, what's the, yeah, exactly. What's the law of sines? Can somebody tell me what the law of sines is?
Ratio.
Totally. Tomorrow you better know this shit.
Something divided by the sine.
That is what a ratio is. Something divided by something else. Does anyone know the law of sines yet?
Sine of A.
Sine A over A. Yeah, sine big A divided by small a.
B sine.
Sine big B divided by B.
Yeah.
Sine big C divided by C. Yes, they all equal each other, yes.
Yes.
And we only ever use two of them at a time, because I don't want to deal with a tri-equation, right? Triple equation.
Yeah.
Can I make, so then law of sines requires me to be able to make a complete ratio, or I could never set up an equation with only one unknown. I'd have more than one unknown. Can we make a complete ratio from this problem?
Yep.
Yes, I have an angle and the stick in its mouth. So I can make a complete ratio. No, go for it. Try to set it up. What angle could you find? What do you have enough information to find right now? What angle could you find? Say again? I can find angle B because I have side B. I don't have shit about C, so he's gonna have to wait his turn. Okay. Sorry if you missed yesterday. We actually constructed triangles yesterday. It was fun. We used protractors and stuff.
Real.
So some of you guys might be like, oh, thank God I didn't come yesterday. We all pretended to have a good time, so just felt good.
What do you want us to round to?
Oh yeah. I'll actually say on the test, but like I either say 2 or 3. So let's go 3 places,
Okay.
just to be an ass about it. So let's see, I'm going to catch up to you guys. So law of sines is what I can use here. Get out of there. So then I can use these two, because that's what I have actual information about. Sine of A over A equals sine of B over B. Now what could happen here? So many things, Jeff. Here we go, perfect. I need more room. What are we gonna have to check for?
Oh, second.
Because if I draw this, let's see, 39 degrees, that's 45, so 39 is like this. I don't know, that's roughly right. A. I'll put B here. I'll put C here. So we know angle, side, side. ASS. This is the one that could give us no answers, 1 answer, 2 answers. Are you guys at all with me? That's how you can tell. If it's a law of sines and I only give you one angle, it will basically be the one you have to worry about. I need you to understand. So this is a law of sines that I only know one angle. I gotta check. I gotta see if I have 2 triangles or not. How do I solve for B? Big B?
Inverse sine.
Yes.
Sine,
So if I take,
6 times sine 39 divided by 10.
oh, here's some calculus for you. Ooh, sorry.
Very
Thanks. That was funny. So if I multiply by 6, right, just multiply by 6, I'll get my sine B by itself. I don't have to cross multiply because the whole idea is just to get this by itself. And then I can do what to both sides?
inverse sine.
Inverse sine, kick ass. die. And then I can figure out what, we're gonna call it B1. So, I did not bring my calculators, so I'm sorry. I'm gonna have to crowdsource this. Make sure you're in degrees when you do this, or else it can get really freaky. Can I take a guess?
4B.
Hold on. Let me see if I can take a guess. This will take me a second. So between 3 and 5. So wait, does that even work? Wait. Let me think. It'll be between. Oh, I already did. I see what we're doing. Yeah, so it should be. Oh, it's almost 90 degrees. What do you think? I don't know if I can do the math. I'm too tired. I shouldn't have tried. I really shouldn't have tried. Did it work? Did it give you an error, or did it work?
It worked.
Wait, just tell me what you.
67.0.
What is it?
67.0.
Alright, sure. I'm too tired, man. I'm like, no, it's not gonna work, Jack. 67.066.
066.
So we'll say 07? Sure. I think I said 3 places. Well,
places.
we'll go 2 places. Why not? I really gotta apologize. I mean, I'm just like, I'm really tired. Okay. What I have to do right now before I go any further with,
Find angles.
no.
Oh, subtract.
Yes, I need to check to see if there might be a second triangle.
Yeah.
And if you missed yesterday's lecture, I think a few of you guys did. Let me see if I can do. I'm not even gonna just remind you guys. This is really good to see. Okay. So I gave us, yeah, so I basically drew it. Here's B, here's A. We know angle A, we know side B, and we know side A. So what could happen is, let's see if I did this right. Yeah. I've got a triangle there, but I could also have a triangle there. And the reason it works, the reason that the base is dotted, is it didn't tell me how long that is. All it told me was the angle. So I know I start here and I rotate by 39 degrees, but I don't know how long this is. So that's why this works and this works potentially. Now, if this is too long, then this poor guy's like, I can't make a triangle. But if I shorten him just a little bit, then maybe there's one triangle. Okay, maybe that's really truncated from yesterday, but angle, side leads to the possibility of no answers, one answer, 2 answers. That's the geometry behind the math. So if there were no answers, when you plug this in, well here, can you guys do this? You plug this in. Can you put in there inverse sine of 10 sine 39 divided by 4.1? Replace 6 with 10.
Yeah, it's an error.
What's the error? Is it domain?
Yeah.
Yeah. So if you get an error, you either type something in wrong, or more likely, your problem has no solution. Because it's the one where it's like this guy's like, I can't reach. Okay. So if you're at home and you missed yesterday, just watch yesterday's video, because I actually recorded that. So right now, there's one more thing up here. So either it's this or it's this, yes? This is one possibility for angle B. That's what we got. The other possibility for angle B would be this. This would be B1. This plus this must be 180. So B2 must be 180 minus B1. Oh shit. That was very quick. So now, when I'm doing a law of sines, and I use my inverse sine, I need to check, is it possible there's another triangle? What would B2 be then? Yeah, 180 minus this will be 112.93. Is that what you got? Yes, okay. So does that work in our triangle? What was the angle that was already in there? 39 degrees. Does 112 plus 39 leave room for a third angle? Yes. So if this would have come out to be 160, the second triangle is dead in the water. Because 160 plus 39 is over 180. That can't be a triangle. But since this guy was not too big related to the angle I already had, oh shit, another triangle could exist. It could swing over and make another triangle. Okay. So I'm going to focus on triangle 1. I'm going to completely solve it. And the funny thing is, if you're really nice to yourself, triangle 2, you do all the same work, you just use this angle instead of that angle. It's kind of silly. So the name of the game in a lot of math courses, Christina can back me up on this, is organization. People that are less organized get lost in their own sauce. You see it all the time. So, how do I get, what do we know? Let me get this back up here. There it is. How do we get angle C?
180 minus the other two.
Yeah, so I've got 67 plus 39 will be 106.07. So is everybody really with me? If I'm looking at just the first possible triangle, now we know angle B is 67. I've already got 39, so what would angle C be? Add those, subtract from 180 to see what's left over for the third angle. Is everybody? Okay, so then we'll get, I think what I just said, 106.07, so we'll get 73.93. Did anybody do that? Or yeah, we should not trust my brain right now. Okay.
Yeah.
Like, we never trust you. Be quiet. 41. Yes, good. That works. Sweet. Now, what's the only thing we don't know then for the first triangle? We have side A, side B. We have all three angles. So we need side C. So when I say solve the triangle, that means find all three angles, all three sides. Whatever we don't know, you got to find it. So there's only one thing left to find. And how do I find side C? Side C? Well, how do I find side C?
A sine C divided by sine.
Something like that, yeah. So I got sine of 39 divided by 4.1, the same thing we used in the beginning. But now I know angle C. So then I can set up that ratio, yes? I can set up the C ratio. I had the A ratio from the beginning, and we used that to get B, because we had information about B. Now I have information about C. So now I can finally go, oh shit, I can get side C. How do I solve for side C? Solve for side C. How do I solve for side C? Oh man, I am newbie. It's gonna be okay. Does anyone know how to solve for side C?
Multiply both sides by C.
Yeah, totally. So here's the, you can cross multiply, right?
Yeah.
But the funny thing is, if this comes up, this goes up, and then this just goes down. Now you guys can get there if you cross multiply, got one more division to do to get C by itself, and then you just shove it all just into a calculator. Shove it all in there. Just be really careful when you put it in the calculator to close the parenthesis. If you leave this parenthesis open, everything after that will be inside of that sign. take it from a person who's actually done that. It's not fun to get your quiz back and everything's wrong. You're like, oh shit. I gotta close my parentheses. What's that, Jeff? Let's see. Wait. That's roughly. You do, Jeff. 1 3 4 split 2 and this one 2 and 3 and 1. 3.5 divided by 7, but it's gonna be more than no. Yeah, it's gonna be around 7. I could be very wrong.
6.2.
Oh, okay, I'm okay with that. Are you kidding me? Tired brain? Huh? Oh, okay. Well, that's good, Trent. You're special, man. I'm sorry. What was it again? 6.261. 6.261. Okay. So listen. Oh, let me put a little C1 on that. The little subscripts are going to save you because everything we just did was about the first triangle. Now, what I'm about to do is just do all the same shit we just did, but starting with B2 angle. So everything's going to change a little bit, but the work I did is going to be exactly the same. So if I look at triangle 2, let me put up here what we know also. This is what we know from the beginning. Oh, by the way, what should I put here? Centimeters, good. This is centimeters. Okay, so we know all this already in this triangle. So what would C2 be? What is it? 151.93, so that'll be 28.07.
Yeah.
Okay. Right? Is everybody cool with that? I know 2 angles, add them together, subtract them from 180 to see what's left over for the third. And then it's whatever I just said, which I completely forgot.
28.0%.
Okay. So it's exactly the same work we did before. So now I'm going to set up this exact same ratio, except... What is that, Jeff? Oh, no. Why is there a point there? Who knows? Nobody knows. I'm going to use this value for C instead of that value for C. So this will be C2. So you see how it's, if you just finish triangle 1 and then do triangle 2, you'll keep everything distinct. You won't, I always get somebody overlap the triangles. Somehow they both exist at the same time, and that's not good. It's like that movie Time Cop, they just sort of meld and disappear. So C2, multiply 4.1 up, divide sine 39 down. What's that, math boy? I don't freaking know. Let's see. Wait. That's what it's gonna be. That's gonna be more than 1/2. That's gonna be less than 1/2. So let's see. That'll be 8.2. So that's that. I would guess like 9.4. Shit. What is it?
3.06.
Oh, okay. I'm fine with that. 8.06 centimeters. Cool. Now, real quick. Sorry.
I said 3.06.
Oh, 3.06?
Unless I did it wrong.
It's the 3.
Oh, okay. I completely did this in my head wrong.
Yeah.
And I think I'm realizing what I did. I flipped a fraction over. Okay. 3.06? Well, this is good. I wish you would have just let me. 3.07? All right. Real quick. In this triangle here, why does it make sense that side C is smaller than side B and A? Why does it make sense that side C is smaller than side B and side A? Why does it make sense? Whose mouth is smallest? Yeah. C's mouth is smallest, so the stick I stick in there is smaller. Over here, side C was actually the biggest. And why does that make sense? Because here, angle C was biggest. Okay. I love you guys.
So for a problem like this on the exam, you wouldn't need us to like draw a triangle, or like sketch a triangle? Would
You don't need to, but it's not a bad idea, but you don't need to.
Because I don't.
It's kind of nice to have a visual anchor.
Yeah, I don't know who would have to like draw a triangle.
Yeah, if you don't want to draw the triangle, you could do these problems without it, because the ratios are just literally by letter. Yeah. Okay. How do we all feel about it? That's one of the hardest problems with law science, because you have two triangles. So if B2, again, would have been 140, that would have worked. 142, that would not have worked. 140 plus 39 is 179, that leaves 1 degree over. 142 plus 139 plus 39 is over 180, that would never work. You can have two angles add up to more than 180, or equal to 180 for that matter. Okay. What about 10b? Can I use law of sines on that one? Huh?
Eventually.
Eventually, yes, but right now, from the beginning. Why can I tell? How can I tell that I cannot use law of sines?
Because you have no.
I can't make a complete ratio. I don't have information about one letter, its angle and its sign. But I am given enough information. So one of the two has to work. So if one doesn't work, the other one does. What is the law of cosines? Which version do I want to use here? Which version do I have to use here? There's 3 different versions of law of cosines there, yes? Since I know angle C, I want to use the one that's got side C in it, yes? So it starts off looking just like what? There, that's right, old Greek dude. But here's the beautiful thing, and I don't know, you can look at it like this, but this is like an adjustment in case it's not a right triangle. Real quick, I can't remember if I did this. What if C is 90 degrees? It would be a right triangle, yes? But what is the cosine of 90 degrees? What's the cosine of 90? I think I heard it. 0, because 90 is on the y-axis, cosine like x hates y. So what would this whole term become? And then I would get Pythagorean theorem. So this is the broader thing that Pythagorean theorem is a part of. If C is 90, this reduces to a squared plus b squared equals c squared. If C is not 90, this is whatever the hell it is. And I look at this like an adjustment. Oh, you're not a right triangle? We'll just give it a little adjustment. It'll be okay. So try that out. Try to plug that stuff in, and I'll catch up to you. This is a giant frickin' triangle, by the way. This is like a crop circle, but it was a triangle because the aliens are wanting to mess with us even more. You guys know what crop circles are? You guys know what crop circles are?
Yeah.
Guess what they are? They're circles and crops. But they're like supposed to be made by aliens. But there were people actually caught on camera that were like smoothing it out. Something I want to point out about this, since you have to memorize this. C is here, the side, angle C. A and B are here, and B are here. So the inside is 2 of them, and the outside is the third one. I don't know if that makes any sense to you. That side goes with this angle. So if there was a B here, there would be a capital B there. And then the other 2 letters are involved in the middle. Okay, maybe. Because you do have to memorize this, because I am evil. Here, let me. So this is, you just throw this in the calculator, yes? And the great thing is you can just throw all of this in the calculator exactly as it's written. Calculator costs enough money. It knows order operations. That's why you had to pay so much money for the damn thing. Well, that's one reason. It's mostly the graphing. But I want to point something out. If it would have been 90 degrees, and this was 6.3 and this is 9, are you guys with me? If it would have been 90 degrees, then this is how big C would have been. But it's actually 105 degrees, yes? So isn't C going to be longer then?
Yeah.
Now, real quick, doesn't it look like this subtracts? But what is the cosine of 105? What quadrant is that? Second. So what's the cosine in the second quadrant? It is. So that becomes plus. And that makes it longer. Now, do you have to actually do anything I just did over here to understand how to do this problem? No. This is a little extra side note to make this make hopefully a little more sense. So if you plug all this shit in the calculator, you get what C squared is. I don't have a calculator, do I? What is it?
I got 150.
150.054. So what's C? 12.25. That sounds about right. Kilometers. So let me know if you got something different crowdsourcing this. So what else do we have to figure out now?
The other angles.
Yes. So now I've got all three sides. I have to figure out the other angles. Now, let me see. I'm going to say something, and if you understand it, it's going to make something a little bit easier to do. If the angle you're using in law of sines is bigger than 90 degrees already, you shouldn't have any trouble when you do an inverse sine. So pretty much when I have something, and I got a few different angles I could choose to do law of sines, I choose the biggest one. So let's try it out. Did I draw a picture of this? No. But what ratio can I make? There's only one. What ratio can I make? What's the only angle I know? Yeah, so the ratio I can make is C's, right? So I can make sine of 105 degrees over 12.25. And now it's up to you. Which angle do you want to find now? I don't care. B? Okay. Sine B over 9. Bam! And then you just throw this in a little calculator. Oh, look at each other. I'm going to pretend like I can do it. Oh, that's right. And then I do the inverse sine. Holy shit, I'm not going to do that in my head. Let's see, it's 0.63. 63. It's a little more than that. 63. So it's going to be between 30 and 45. I would say 38 degrees. I'm so okay if I'm wrong. I don't even know. What is it?
45.
Is it really 45? Okay. I'm close. I knew it was over there somewhere. That's crazy. It's exactly 45?
45.2.
Okay. So then I take the inverse sine, and then you just throw this in the old calculator, and you get 45.21. So what's the only thing we don't know? Angle A, and that's easy to get because we know angle C and we know angle B. So angle A is trivial. You get 29.79 degrees. You guys with me? If I do two angles, add them, subtract from 180, I I think you get 29 point, whatever I just said. Yes, 29.79 degrees is what A should be, I think. Woohoo! 60% of the time, I'm right every time. Alright, so I definitely wanted to do number 10 because I did not have time to finish it on the practice test answer key. Any of these you want to take a look at? Yes, sir.
Can you look at number 8?
I was wondering how long it'd be until somebody asked me about these hobbits. Just take the Eagles. Just take the Eagles hobbits with the shit. Okay, this is probably the hardest problem on this practice test, I would guess. So you guys might, and one little thing, this is a little artifact from a different iteration of this problem. Don't worry about the 2. On the answer key, I just kind of deleted it. I didn't mean to put that there to make it weird. But I used to have an X1 and an X2, and then I changed what kind of problem it was. Okay. So on number 8, one funny thing about number 8 is you could potentially use like a law of cosine or cosine. Well, let's pretend like we don't know that. How many right triangles are in there? 2. There's one with a big nose, and then there's a shorter one in there. Yes. Do I give the first shit about either one of their hypotenuses? Do I? Do I care about the hypotenuse of either one of these? Am I, as a hobbit, am I trying to set up a zip line from the top of Mount Doom where like, we killed Sauron, didn't it topple or something? Oh, once all the lava comes down, we're going to set up the zip line. No, we're not going to do that. So, I'm not going to use sine or cosine because I don't care about, I don't know about, and I don't care about the hypotenuse. This side I know stuff about, and this is what I want to figure out. So like somebody just said, tangent. So for the short little dude, this little tiny dude, the little tiny dude, what can I write? Tangent of 35 is?
H over X.
Totally, H over X. Now some of you guys might be like, look at us go, we wrote something. How does that help us? Okay, well, you know. How many unknowns are there in what we just wrote? 2, that sucks. So I need another piece of information because there's 2 things I don't know. So if I look at the bigger right triangle, can I write a similar thing?
Yep.
Tangent of what angle's in the bigger right triangle?
32.
32 equals
H over.
H over, and the big mistake I see is somebody says H over 1,000. That don't make no sense because that's not in any right triangle. H over, yes, 1,000 plus X, or X plus 1,000. So, out of the equations we just wrote, which side do we care everything about? Which variable do we not give the first shit? We don't care about X. We don't care about it. I want to know what the hell H is, yes? So here's what I'm going to do. I'm going to solve the first one for X, because then I can plug that into the second one, and I won't have any X's. Sounds amazing. So watch this. How do I solve this for X?
Multiply both by X.
Yeah, if I multiply the X up, I can divide the tangent down. These 2 change places. That's a great algebraic trick to know. If P over M is W, P over W is M. And this is kind of dumb. If P divided by one slice is the other one, then P divided by the other slice is the first one. Okay, whoop-de-doo. It's like 10 divided by 5 is 2, 10 divided by 2 is 5. That's what that says. So X equals H over tangent 35. Let's kind of clean this up a little bit. Can I do the same kind of thing here? Take this and multiply both sides. and then divide by that. Now again, remember, this is probably the hardest thing on this practice test. Do I know what x is now? Sort of. Do I have an expression for x? Yes. Do I see x somewhere else? Yes. Wherever I see x, I can replace it with what I know it is. And then will this equation now have only the variable we care about?
Yep.
There you go. That's substitution method, right? You substitute the variable you don't give a shit about, so you make sure you have just the variable you care about, and then you can solve for it. You put algebra in my trigonometry. Okay. So if I take, and then you guys might be thinking, well, that's great, Jeff. That's really great. Well, what the hell do I do with that shit? Well, you already know. You know exactly what to do. What are you eventually trying to do when you're trying to solve an equation for like x? What do you have to do? Get all of your
H was the same.
yeah, in this case, I'm trying to solve for h. I get all of my h stuff on one side and all of my non-h stuff. What's the only thing in the wrong place then? What piece is in the wrong place? I don't have an x anymore. Yes! I see. Okay. This is in the wrong place. I want everything with h in it on one side, everything without h in it on the other side. This is the thing you've been doing with algebra since you first started doing algebra. Get all your x's on one side. So whatever you're trying to solve for, get everything that has that in it on one side. You've been doing this forever. Now, a really good question would be, okay, now what, Jeff? How many h's are in my equation? No.
One.
There's one. I think I said this before you.
Yeah.
There's one that somebody distributed, so let me undistribute it so I can solve for it. So that's one reason why, normally in early algebra, you get all your x's on one side, because then it's 2x plus 3x is 5x. But now we're realizing, even if they're not like terms, I can factor the damn h out. So then I have one of them, and then I can solve for it easy. What am I left with if I factor an h out? Don't overthink this.
1 over
Good.
32 degree minus 1 over tan 45 degree.
Now this looks gross. I don't care. Because we're almost at the point where we just let the calculator worry about it. What's the next step? How do we get h by itself? What do I want to get rid of?
Divide by.
Yeah, don't let the ugliness of this poor little dude worry you. I want h by itself. It's h times shit. Let me divide by shit. So you put in your calculator exactly this. 1,000 divided by parentheses 1 over this minus 1 over this. I have to apologize if there's any major Tolkien fans out there. I thought Past Jeff set this problem up to come out with the right answer. I was like off by 1,000 feet or something. Oh. I think it's 5,000 something. I got. Oh, did I plug it in the calculator? Oh no. I was making this answer key when I had no calculator next to me. Who's got that answer? Can you put that in the calculator? So do 1,000 divided by parentheses 1 over tangent 32 minus 1 over tangent, right? Make sure you're in degrees.
5,807.6.
That sounds about what I got before. 5,807.6?
Yep,
Feet? Feet, yes. And I think the actual height's like 4,000 something. I'm very sorry.
A lot of shenanigans.
Shenanigans?
Yeah.
Oh, yeah. Like I said, this problem's not the most obvious, but basically, whenever you have more than one variable, you solve for the one you don't care about, so you can replace it with something that has the one you care about.
Yeah.
Then you get all that on one side and factor it out. It almost always works like that. It's crazy. Almost always.
The idea is that we're gonna have a question kind of similar to this on the actual.
Yeah, the one I'll give you won't be as crazy as this one, but you will have something. We've seen some kind of crazy ones, haven't we? Didn't we do the one with the guy looking out the window?
Yeah.
Yeah. Okay. So I'll give you something that would be an upper bound of the level of the.
On
Yes.
number 3, how do we do the arc length?
I was hoping you would know. 3. Where did I put the paper? I have no idea. What's number 3 say?
Find the arc length of the segment of the
Oh.
dartboard. There's 8 to 20 segments at 8
Oh yeah.
segments.
Okay. Who remembers the arc length formula?
S equals R theta.
Yeah. S equals R theta. What is really important?
It has to be radians.
Yes. Whenever an angle is in the wild, meaning not in a trig cage, that angle is not inside of a trig function. It has to be in radians because that's the only angle measure that makes physical sense.
So would that be, so the radius is 225 millimeters?
Yeah, I don't remember. Let's see. Yeah. So the radius is 225. And the angle, what's wrong with the angle?
It's in degrees.
So how do I change that to?
Radians, so it's 25.8.
Yeah, so it'd be 180 pi, so it'd be pi over 10, and that's what you throw in there. Yeah. So if they give you degrees and it's supposed to be radians, you just gotta take a minute, change it to radians.
And that's the arc.
That's the arc length.
For the total area.
Now, in one sector, in one piece of this, there's an angle of pi over 10. There's 2 different ways to do part B. One way to do part B is just to get the area of one segment and then double it, yes? Because they got 2 segments, yeah? They got 2, yeah. Does that make sense?
I would just find the full circle and then divide it by 20.
Oh, I see. So on the test, I'm going to say specifically, use, did I say it here? Use the, nope. I'm going to say use the arc length formula, use the area formula.
Okay.
Yeah. Just so we get used to this.
So B is that form.
Yes, totally. Just to remind you guys, area of a triangle is 1/2 base times height. The base of this kind of a triangle is r theta, and the height is r, so that's where 1/2 r squared theta comes from.
Okay.
So if I find the area of one segment, right, r was 225 or something crazy, I can then just double that because I want 2 segments for part B. Or I could plug into this equation, not just pi over 10, but pi over 5, like 2 pi over 10. Just double the angle that I plug in. Mathematically, I'm doubling it either way. So it comes out the same answer. Okay. That's 225, got smushed in there. How would you find the perimeter?
Multiply the.
How long is this?
22.5
It's r. How long is this?
also
R. How long is this? R theta. So if I tell you find the perimeter of one segment, you would take 2 radiuses plus the arc length, yeah? Because you want to go all the way around that slice of pizza. Or this, in this case, the piece of the dartboard. What did I do with that? I really don't know what I did with that. Oh well. Here it is. Yay! Let's see. Are you guys cool with 6 and 7? The 2 graphing ones? No? Okay. Like, what's the period of tangent? Well, period of tangent is pi. And then you're right. And then to find the new period for something I give you that I've shifted and done stuff to it is pi over k. I love it. In general, the new period is original period divided by k. That's why I signed a cosine of 2 pi over k. Where does tangent live between? At least the cycle that we chose to graph. Because there's an infinite number of them, so we only chose one. Which one did we choose? What's it live between?
Pi over 2 negative.
Negative pi over 2 to pi over 2.
Does it matter what order we do that?
Huh? It sort of does, because you wouldn't want to say something like, we have everybody come here, everybody from 80 to 12 years old. Doesn't that sound a little weird? It's always small to big, yeah.
Okay.
How tall do I have to be? Anywhere from 7 foot shit to 5'2". What are you doing to me? Right? You're like, no, small first. Okay. Sorry. So here, what is one thing you have to be careful about? Like what's the amplitude, and why did I put it in quotes?
Because it doesn't have a.
It doesn't truly have a ceiling, but
Just have a
that
line.
does tell me something about the first and third steps as I move through it, where it goes. But what is the amplitude? Good, 3. The amplitude can't be negative, because that would be like going in like Quaid. No. I don't know if anybody got that reference. Total Recall. Amplitude is 3, but what's this do to me?
Flips it.
Yes, so tangent normally looks like this. Why? And then now it's going to look like. Okay. It just flips it, yes?
Yes.
Okay, so the important thing about graphing any trig function is the reason I do, to be really honest, the most important step in a trig function is step size. Because everything happens at those steps. So tangent normally goes wall, amplitude low, 0, amplitude high, wall. This one's just going to kind of flip that over, yes?
Yeah.
So if you know, like sine goes 0, max, 0, min, 0.
Yes.
So as you step, you know exactly where to put the outcome. Amplitude's 3. What's the new period? What's the old period? Pi. And what's the k? Pi. K is anything in front of x here. It's the multiplier of x. New period is 1, so what's the step size? 1/4, sure. And then beginning and end. Now this is really key, because my other class, they were using 0 and 2 pi, which is silly. You just told me where tangent begins, the cycle we chose. Where does it begin? Negative pi over 2. And it ends, so it begins when the inside is equal to negative pi over 2. And it ends when the inside is equal to pi over 2. So watch what I can do. Does every term have a pi in it?
Yeah.
So I can divide by pi. Then I just add 1/4. What's negative 1/2 plus 1/4? Negative 1/4. Cool. Here, I can kill all the pi's again, which sounds like a travesty, but we'll be all right. And then if I add 1/4, I'll get 3/4. Now, why is this a good thing to see? How far apart are these? What's 3/4? Minus negative 1/4. How far apart are these? 1, which is what the period's supposed to be. So what's going to happen at negative 1/4? Yes. Yes, wall. And then my step size is 1/4. That kicks ass. So one step gets me to 0. Another step gets me to 1/4. Another step and another step. And what's nice is 3/4 is where I was supposed to end. Yes? Now tangent normally, first step in would be down here. But since we flipped it, first step in is up here. Now I just have to indicate my amplitude. So first step in, tangent's normally here, but it's been flipped. So now it goes like this and like this. Okay, that's not terrible. I can live with that. Just when you draw it, make sure that I can see, you know you're supposed to be approaching those asymptotes. I'm kind of lenient on tangent because even, I have trouble with the curve. It's very weird. It's very slight.
So you said it to find the phase shift. So
Oh yeah, phase shift I left out. How do I find the phase shift? What do I have to do with this? Yeah, what comes out? I have to take a pi out. So then what am I left with? 1/4, yeah. So what would the phase shift be? 1/4 to the right. Yes? So why doesn't that jibe with this? Because we didn't start at 0. But I want to show you something. Tangent, right in the middle, normally goes through 0. Yes? If I shift everything to the right 1/4, it should go through that at 1/4, does it? Yep. So one thing I've never really thought about until this semester is I could teach the middle and move it and then step both ways. I'll wait for the middle. Maybe I'll start doing that next semester. Too bad for you. Missed out on that. It's a neat thing. You never learn everything. It's crazy. Okay. Here, I think I'll go ahead and give you guys the answer key, so you can see if there's anything that looks freaky. I'm a little worried about my diabetes. I haven't been here a few classes. More of my handwriting. You're welcome. So you can see back here, we did this in class. What did I get? Oh yeah, sorry. It was whatever it was, 5807. I meant to get a calculator, and apparently I forgot to get a calculator. Oh, I did this in red ink, neat. But remember, that's how you get secant and cosecant, is you just draw the appropriate original graph and then you put the cups. Whee! Okay, okay. Oh yeah, here's the other way to do that one. Bow, 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 bow. Okay. And then and there's a big ass thing we know we were gonna get for 60. So let me know if any of that looks wrong, or if you still have questions on any of these. We could even do other problems like some of these if you want to focus on any of them. Up to you.
Practice with graphs, so.
Yeah. Oh. So let's see. What if I said I want you to graph cosecant, 2 cosecants of what you got, Jeff? Pi over 4x minus or plus, let's say, pi over 2. I like it. Beautifully gross. I love it. So I wouldn't leave you to your own devices. I would say find the amplitude. So what I'm going to do is I'm going to pretend like I said sine here. Why am I going to do that? I'm going to do all the steps as if this was a sine question. Why?
Because you can just flip it out.
Yeah, I can do the cups on top and bottom. Cosecant is 1 over sine. So if I graph sine, cosecant will just be flipping it. So it's, what's really cool, by the way, real quick, I gotta say this, because we're not gonna do this semester. Do you guys know what an ellipse is? An ellipse is this, yes? And a hyperbola is basically the same idea as cosecant and secant, because a hyperbola just goes out. So an ellipse has these two come together, and a hyperbola has those two go out forever. So it's kind of similar to how sine and cosecant are the same thing. So let's see. If I pretend like that's sine, my amplitude will be 2. How do I get my phase shift? Totally. So let's see, how do I factor this thing? I gotta take pi over 4 out. So if I take a pi out, that'll be a 1 up top, yes? If I divide by 1/4, that's when I take something out, I divide it out. So here's one way you could do this for yourself. You can write what's here, and then you can multiply by the reciprocal of what you took out. That will always work. Not really sure why I've never shown you that, but I think today I just decided to stop being an asshole. So the pi's cancel. 4 divided by 2 is 2. So we get the inside is pi over 4 times x plus 2. So what is my phase shift? 2 to the... What is my new period? What's my original period? 2 pi. And what's going to divide that by? What do I always divide the original period by? The multiplier on the x. 2 pi divided by pi over 4 is 2 pi times 4 over pi. Pi's cancel. 2 times 4 is 8. What's my step size? How far do I have to go to fit a cycle in? How far do we have to go to fit a cycle in? 8. And how many steps are we going to take? 4. So my step size is 2. Are you guys with me? Are you guys all right? So this is one I just made up in case anybody missed that part and is wondering where the hell this is coming from. How do I get this thing started? What do I do? I don't have to do the beginning yet. Maybe we've done enough of these. You guys realize we don't have to do that. Sine normally starts where? Yes, 0, 0. Yes? But we've shifted that how? How do we shift it? To left. So now I'm going to start at -2. And every step I take is how big? 2. So first step goes to 0, next step goes to 2, 4, 6, 8. So I end where I'm supposed to. I think, wait, 1, 2, 3. Oh, I took one too many steps. How far is this? From here to here? 8. That jibes with my period. Yes? Now, sine, like we just said, starts 0, and then it goes high, 0, low, 0. I'm going to dot this. And then how do I do my actual cosecant? Yeah, where do I put my vertical asymptotes?
At -2.
Good, because that's where that's 0, there, and now I've got like walls for my cups to live in, which is always nice for, you know, to keep the cups constrained. That's how you do a cosecant graph fully, just by itself. You do the dotted line for the sine or cosine, and then you do the cups, and that's your actual graph. Yes?
How do you do a cotangent?
A cotangent is just like a tangent, except cotangent normally lives between 0 and pi. And it has this, it naturally looks like this. So you do all the same shit we did with tangent, it's just that that is my starting graph. And then I move it and so forth. Yeah. Yeah.
Can we do 9C?
Oh yeah, that one's a good one. I like that one. The first thing on 9C is, do you understand what the shit it wants from you?
Yes.
What kind of answer should I get?
Fraction. Or-
Yeah, I'm probably gonna get a fraction that's gonna involve x.
Yeah.
Because there's a part of this I don't know. But I just put x where I would put the number if there was a number there. I don't let x immediately bother me. It's going to make things look a little worse than normal, but that's about it. What do I do for myself to answer this question? What is this physically, geometrically? What is it?
Triangle?
No. It's something that lives in a triangle under the sea. Huh?
So X and Y?
No. It's the ratio that's inside of it, but what is it? What do you put into a tangent? Tangent of what? What do you put into it? Angle. So what comes out of an inverse tangent? Angle. So if I put an angle into the function, I get an angle out of the inverse function. That's how we know inverses work. They switch the x and y. They switch the input and output. What angle is this? It's the angle that lives in a specific triangle. What do we know about the triangle it leaves? Leaves? Sure, Jeff.
Y is 4x.
Yeah, the y side is 4 and the x side is x, because we know, like somebody said back there, this is the ratio related to tangent, which is y over x. To answer the cosecant question, do I have everything I need? What does cosecant need? What ratio is cosecant? 1 over sine, beautiful. And what ratio is sine? 1 over cosecant? No.
Or Y over R.
So then cosecant is r over y, yes? Or a hypotenuse over the y side. So what's the cosecant? Well, then what do I need?
4 squared.
Hypotenuse. Yeah, square root of x squared plus 4 squared. So then what's the cosecant?
4 over.
No, that would be sine.
square
I
root
want the
of
cosecant, yes.
squared plus 16 divided by
Triangle. So an inverse trig function is an angle. I can draw a representative triangle that it lives in. And then I can answer any weird ass question that I ask. So look for those kind of problems, right? And just do them so your brain doesn't get them later and start doing weird ass things. Okay, let's see. Yeah, so like part B, the one thing you want to do for yourself in part B is to tell yourself that's 3/1. So you see the full ratio, so you know what to put on the sides. Any whole number that's in there, I can just make it to a ratio. Help me out. Look what I did on this guy. Aren't I neat? Sine is 1 over cosecant, so the angle that makes cosecant -2 is the angle that makes sine -1/2. You can always do that. And I don't blame you, because we don't work with secant and cosecant and cotangent as much. So I kind of wanted to put it in terms of the main three. Yeah? Draw my outside. Let's see. What else is weird? I think we talked about almost everything on the practice test anyway. Were there any questions from the quiz? Did the quiz go all right? The average was like, I can't remember exactly, but it was pretty high. Oh shit. I totally did. Does anybody want a copy that didn't take a quiz? Anybody want a copy? Oh, I was like, what's happening? Shut. The sound of the day. Shut. So Christine's got some, are these altered office hours? Or are these?
Yeah, it's gonna be Mondays, Thursdays, 2:30 to 3:30, in room 216 in the Math and Science Center, if anyone wants to come.
Mondays and Thursdays, 2:30 to 3:30?
Yep.
Okay. And you guys are, I'm pretty sure I've told you, you can go to the CISL, I've seen several of you. And then you can get help from other instructors. If I don't make any sense, you know, maybe some of these other people will make sense.
And I'm in the
And
CISL
then-
as well I'm in the CISL as well on Thursdays.
There you go.
At 10 a.m. to 12 p.m.
Hey, that's perfect, because that'll be before class tomorrow. How many of you guys have signed up for calculus yet? Okay. Oh, okay. Just, I'm pretty sure I talked to you guys about this, but do you know that I talked about it, even if you fail this class, you could still take 080, 180, did I tell you this? You didn't even have to take this class, so I appreciate that you're here. It's a really smart thing to be here.
had to.
No, you didn't. Because the state said, hey, you didn't know this, anybody can take calculus. And we're like, really? And they're like, yes. So basically, if anybody comes wanting to major in STEM, we have to let them take calculus. Now, we can make them take a support course, which is OA at the same time. So you get to learn algebra, pre-calculus, and calculus all at the same time. The state says, that should work. So I might be showing how I feel about this, but it's much better to take this class and then take calculus. That's much better. But you could, even if you fail this class, I would still highly recommend you retake this because you don't want that failing grade on your transcript. But if you're really pressed for time, you can take OA to 1A. With me? And I would highly recommend then to give yourself more time because you're gonna have to go to the CISL and tutoring support for sure if you do that. Okay. If you pass this class, you can go straight into just straight 180 if you want to. So everybody with me?
Kind of.
Or it's not 180 anymore for one thing.
It's like siege.
Yeah, C2210.
Yeah.
But again, it came from the state. The state obviously knows the right way to do things because that just makes much more sense than 180. Yeah.
I was just gonna ask, how long is the break between now and fall semester?
Fall starts August
Yeah.
18th or whatever the shit that day is, somewhere around there.
And then, okay,
August
so,
20 something.
yes, okay. Wait, so the summer course is 6 weeks, right? But it goes from
June 8th through July 17th or something like that. I can't remember.
Did it go to class?
Huh?
Did it go to class?
Yeah, there are some like 8-week, 4-week, and 6-week. I think math primarily does the first or the second 6 weeks of the summer.
Yes, you're correct.
Sweet. Ooh, thank you.
Could I head out?
Totally. If you're ready for tomorrow, you can head out.
Okay.
See you, Trent. Students sometimes don't trust me. Like, you're gonna leave and I'm gonna go, all right, the answers to the test are. If you take like Calc over the summer, you can take Calc 2 in the fall. I teach both classes, so you can either take me or you can avoid me. There's other people that teach 280 in the fall. I think we're only offering, do we offer 2 180s in the summer? I can't remember. I might be the only choice, but I can't remember.
Yeah, how does the summer class work, by the way? Like, I know you just like online stuff, so that's,
Do it again, sorry.
like, how does the summer class work?
Same as this, just 6 weeks.
Yeah, okay, but yeah, it's still in person.
Oh, hell yeah.
Okay.
I will only ever teach online if I am forced to by global pandemic. Ever. I hated it. Oh my god.
This one's where you want to take different classes online.
Yes. We don't talk about our social knowledge because it's hard for me to stay professional like you. I got that on camera. That's good.